Hi all and welcome back. Today I'm going to take you on a journey with me. I'm exploring Apache Airflow today, a job scheduling system. Let's jump right into it. Job scheduling systems are very important components in IT systems, especially when it's about to realize business processes which are typically working on huge volumes of data. One good example are banking transactions, where a banking transaction is initiated whenever you are initiating actually a money transfer and waiting for it to be realized. And this job behind this is actually executed once a day, overnight typically. Another good example is the generation of reports and printing these reports at day X within the month. This could be or can be a data analysis report containing statistical numbers. And the last example is data integration, which could be a repetitive updating task of information or database records at specific points in time, or which can be also triggered by internal or external events. And now we are going to focus a little bit more in detail on Apache Airflow. And let's go over the features. So a main feature of Apache Airflow is programmatic workflow orchestration, which allows us to completely define our workflows in code or as code. We can schedule workflows and we can monitor those workflows. We have also the feature provided by Airflow to automatically retry on failure. So whenever a task fails, it is retried. Or Apache Airflow is going to retry to execute this task. Then we have scalability, and Apache claims that you can schedule or define any amount of tasks and workflows you want, and it's nearly unlimited. The only limitation is in terms of computing resources you provide to Apache Airflow. And we have a web UI, which is offered to users for interaction with Apache Airflow, a graphical interaction. And it's also exposing a Swagger documentation page where all the API endpoints are listed. The typical use cases a lot of companies are describing are notifications on jobs completion. So whenever jobs completing, you have some systems you can connect to Airflow, some messaging systems, including message queuing or message queues, for example, AWS SNS or SQS, or chat systems like Slack, or mail. So you can send a notification when the job is completed via mail. Next, you have support for sequential and parallel tasks. So all the tasks you specify can be either executed sequentially or in parallel if needed. And this also allows us to express a hierarchical job structure with dependencies. So you can specify task execution and dependent task execution, which is pretty cool. And we have also dynamic tasks, which is actually the possibility to trigger our task via external events, for example, or internal events, like I said before. And external events in this context could be dataset changes. There are sensor components, for example, this SQL sensor, an object in Apache Airflow, which is observing datasets and detecting changes and reacting upon it, or triggering these jobs, the tasks. But we also have the possibility to do or execute API calls. Next, or furthermore, we can extend the functionality of Airflow by defining our own operators, custom operators and hooks, our own templates actually. And we have also the possibility to manage infrastructure with Apache Airflow, and the best use case is, for example, a Kubernetes cluster which needs some objects to be created, and this is when you can use Apache Airflow. Another use case is backfilling of data, and what this is about is that we can rerun a particular task for a certain point in time for a specific data set, for example, if we need to. And the last one, we have a command line interface, which allows us directly interact with Airflow, which is also pretty cool. Important facts about Apache Airflow. It is open source. It's written purely or using Python all along. And it is offered as a managed service by many cloud providers, public cloud providers, for example, Amazon. We have also GCP, we have also Azure, but my focus personally is AWS. So I'm interested in this service, the Amazon's managed workflows for Apache Airflow. My personal requirements for a job scheduling system. I have a situation where I define some requirements which this job scheduling system which I want to use is offering several features, I say. It should be open source. It should be easy to use. So when I said Airflow is supporting Python only and is completely based on Python, then it's about the programming language, of course, also that it should be easy to use, and Python is quite easy and simple and straightforward to use in this case. Then I should be able to trigger jobs on demand as I need it, or do some API calls at least to trigger the job. So either event-based or by API calls should be possible. This is one of my criteria. And it should be notifying when jobs are completed, ideally by message queues, or it could also be, from my perspective, via SMTP mail. Then we have, I want flexibility in terms of integrating existing code. We have already many applications realized or implemented in Python, and I want or need to migrate these applications into Apache Airflow, possibly. And this should be easy from my perspective. I don't want to adjust the code to actually be able to use it in Apache Airflow. I just want to easily integrate by specifying maybe only the files and specifying the imports. This is what I want. And what is optional? An optional criteria for me is that I should be able to deploy this platform locally via Minikube or other tools to be able to test quick and dirty an upgrade, for example, or a quick pipeline, an easy pipeline. It's just a good to have or nice to have for me, but it's not mandatory. And last, it should be offered as a managed service by AWS, which it is in this case. Then we are going over the concept of Apache Airflow. We have the concept of tasks, which are basic units of execution in Apache Airflow. And we have three types. We have the operator, which is some kind of predefined tasks. See it as a template, which we can use and reuse, of course. And we have the sensors. I was talking about the SQL sensor before. It's just another kind of task, which is a special case of task or special subclass of operators actually, which is only waiting for certain events to occur, so external events. And we have the task flow decorated at task, a special case of task, which allows you to write custom Python functions which are then packaged or can be packaged as a task. Next, we have the direct acyclic graphs, which are the DAGs, the main concept of Airflow, which are containing one to several tasks or consisting of tasks actually. And the DAG is defining the actual dependencies and relationships between those tasks. It dictates also the order of task execution. So this is where we specify when which tasks need to be executed and which task is dependent to which other task. The core components of Apache Airflow, we have a scheduler, which is actually monitoring the tasks and DAGs and triggers task instances itself. We have a web server, which allows the interaction between the user and Airflow, and in fact is a graphical user interface. So whenever you want to manually start a task or DAG or trigger a DAG, you can do it also via the web server, via this graphical user interface. You have also the possibility to keep in mind the Airflow binary. Then we have the worker, which is which actually is executing the role, the tasks given by the scheduler. It is the workhorse of Airflow. And we have on the next slide the Postgres database, which is also deployed when it's about the Helm chart. If you use the Helm chart, there are several ways to install it. I'll use the Helm chart. I didn't mention it before, but this is which comes with the Helm chart. This is Postgres. This is just for storing the metadata about the tasks and the DAGs itself and the executions. We have Redis, which is realizing the role or functions as a broker, forwarding messages from the scheduler to the worker. And we have the triggerer, which executes deferred tasks, so some kind of async loop. So let's do the favorite part from me. It's the demo. I have already prepared a Kubernetes cluster using Minikube. What we are going to do now is we are going to install Airflow via Helm chart, which you can find on the official installation guide of Airflow. And then we are navigating to using official Airflow Helm chart section, where we find another link, which we are going to click on, and it will take us to a document which is describing the commands. This is what we need to execute before. We need to add the repo, which I already did. And now we need to install the components, the Airflow chart itself. Using this command, we'll get a clean installation of Airflow. Means that it's not pre-populated with any sample code with sample docs. This is the one we are going to install in production maybe later. I have to specify some environment variables in order to activate the samples, which I'm not going to do right now. I'm doing something different. I want my Airflow scheduler to pull my sample docs. I just copied a sample doc from the official Git repository for Airflow and committed and pushed it into my special dedicated repository for Airflow. And the example bash operator.py, this is the one I copied from the official repo, is residing in the root directory of this repository. And we can go quickly over it. We have the DAG definition, a little bit of anatomy here of the Airflow component DAG. This is how you define a DAG, actually, and there are the tasks, which you see here. And this is just the specification of the relationship between those tasks. I'm not going into detail right now here because I just want to show you how the installation is executed or how we can install it and sync our example operator, our example Python script. So just take it as given, and we are continuing with the actual Helm command. And I already have it here on my command line. You see it, this is the base command. We are going to install it and letting it create its own namespace. And here's the point where it gets interesting, because I'm setting or activating the git sync. setting the repositories to pull my DAGs from, setting the main branch, because it's in main. You can specify, of course, any other branch. And then I'm setting the subpath, which needs to be set at least to empty. And because it's in the root directory, my sample DAG, I set it to empty. Let's execute it. Installing it might take a while until it's installed. Now Airflow seems to be installed. Skipped a little bit. And there you see there's Postgres, there's deployment status, and we have some keys generated. And hopefully we see all of the components. It's under, or the pods should be under namespace Airflow. And there they are. We have Postgres, we have Redis, we have the scheduler, we have some other component, we have the triggerer, web server, and the worker. And now we can actually use the port forward command to forward the web server to localhost. It's running on 8080, so I will map it also to 8080, and we'll check what we'll see. Default credentials are admin for username and password. And there's the example bash operator which I created and uploaded into my Git repository, so the sync worked. And we are ready to go. We can just execute this DAG here on the right side using the play symbol, trigger DAG. But maybe let's go over the properties first. So we have the DAG name, we have the owner, we have the runs, which are counted to four successful times of execution. We have the schedule, the last run, the next run, and the recent tasks. And here we can see all of the different states a task can be in. So we have running, we have success, and we have skipped also. There are some tasks which are just a skip. We will go over the task anatomy and DAG anatomy in more deep in another video, but not for today. I'm just showing you how to execute it, and yeah, let's do it. Let's execute it. The job is expecting a parameter which can be anything or nothing, actually, as defined in the Python script. We can also see a JSON structure here of the input. Let's just trigger it, leave the defaults, and we can see the DAG is queued for execution. And we should have a 5th successful execution right now. And we can see there was one execution which was not triggered by an external trigger, but by the scheduler, and the input was none. And the later executions have all been triggered manually, so an external trigger. And we also have, I think it's called run config there, the input. And if we click on this execution, we can see a graph. The DAG is shown as a task structure, and we have all of the tasks which we have defined in our DAG in the Python script, shown here in a visual graph. We have also some other tabs. We have a Gantt diagram. We have some more details about the DAG executed, when it ended, when it started, and the last status. Runtime was manual execution. Duration was 3 seconds. Last scheduling decision. So we have some details here. I think usually there is also the path to this Python script which was executed, but it is not shown. We have also a code tab which shows us the actual code which was executed, but unfortunately we cannot execute it or re-execute it here in this view, and we cannot edit it interactively. But I think we can live with it. If we want to edit this code, we need to edit it in the repository and commit and push it, and then we have to sync it. The scheduler needs to pull it again. And that's it for today's session. I think I make a break here and I'll continue with some other topic. I think the anatomy of tasks and DAGs will be the next topic for me in the next video. I hope you enjoyed this one, and maybe I'll see you next time.